In today's class, we will see the future construction. That is actually the part of future transformation. Okay, when come to future transformation, there are future construction and future extraction. We have already seen this future extraction, and in today's class, we will see in detail about the future construction. There are two main topics here. First one is encoding categorical nominal variables and encoding categorical ordinal variables and transforming numerical continuous feature to categorical features and text specific feature constructions. So these are the four topics we will see in today's class. First, let us see the future transformation. Here, the future transformation engineering is an important prerequisite for any machine learning model in data pre-processing. Okay, so the given data set, the volume may be very huge. Okay, that data set will be transformed as per our requirement. Okay, so we cannot use all the data for our learning model, so we have to extract only the required data. Okay, here all available attributes of data set are used as features. As I already told you many times, all the features, that is all the fields in the data set, are called as features. Okay, and there will be data with different magnitude, and we have to scale down different features to the same range of magnitude, right? Here, for example, register number is having a list of register number for students, but when come to date, here we are having three different information, that is date, that is day, month and year, isn't it? So here only one data is here, but when come to date, three different data items are there. Okay, and we have to scale down all the features into same range of magnitude, right? Because most of the algorithms will have more important to the features with high volume. Okay, that means some of the algorithms will give more importance for this date when compared to the registered number, because it is having more volume of information. Okay, and this will lead wrong predictions of and faulty models. Okay, that means we have to scale down all the attributes into same magnitude, then only the model will give better result. The model will give better result, right? Let us see one example for this. That is, we will take one document, and the document should be classified into spam or non-spam. Non-spam. Okay. So based on the words which are used in the document. Okay. All the words are called as the bag of words. Bag of words means all the words which are used in the document. Okay, when come to feature space, all unique words are called as a feature here. All unique words, right? And this will easily be a feature space of few hundred thousands of features, right? If we are using the, it is a class. How many these are there in the document? Okay, yeah, is a different class. Model is a different class. Okay, likewise the unique words are selected and that will become a feature here. And if we start including bigram or trigram, bigram means 2 words, trigram means 3 words. Okay, along with the words, the count of features will run in millions. Okay, so thousands to millions it will increase. Okay, so for dealing this particular problem, we can use future transformation. Okay, and in the future transformation, we are going to implement the dimensionality reduction. That is, we need to reduce the number of features. Okay, so that we can implement the learning algorithm on that document. Okay, the document feature should be very much reduced. Then only the learning algorithm will produce somewhat a better result. The goals of feature transformation. The first one is achieving best reconstruction of original features in the dataset. Okay, that is best reconstruction of original features. The original features will be reconstructed so that we will get only the required features. Second one, achieving highest efficiency in the learning task. So suppose if we are using only the required reduced number of features, then the efficiency of learning algorithm will get very much increased. And there are two main categories of feature transformation. First one is feature construction and second one is feature extraction. When come to feature construction, the feature that is encoding categorical nominal variables, encoding categorical ordinal variables and transforming numeric continuous feature to categorical features. Okay, so the continuous features will be transformed into categorical features, right? And text specific feature construction. So these four will come under feature constructions. Okay, when come to feature extraction, the principal component analysis, singular value decomposition and linear discriminant analysis. So these three topics we have already seen in our previous video itself, and that will come under feature extraction. And now let us see the feature construction. Okay, the feature construction involves transforming the given set of input features to generate new set of more powerful features. New set of more powerful features. That is, already we are having a set of features, and from these set of features we are going to generate new and more powerful features. Okay, for example, student database, we are having serial number mark 1, mark 2, mark 3. Okay, so from this mark 1, mark 2, mark 3, we are going to generate additional feature called total and average. Total, which is equal to mark 1 plus mark 2 plus mark 3, because when compared to mark 1, mark 2, mark 3, the total will give more information as well as the average. Okay, simultaneously the average will also give more information when compared to individual marks, isn't it? So these two are newly generated more powerful features. And let us take another example, the real estate data, and which is having uh, the details of the apartments sold in a specific region. That is, the data set having some features, that is apartment length, apartment breadth and price of the apartment. Okay, they will give length, breadth as well as price. And if it is used an input to regression problem, okay, then the data can be the training data for the regression model, because we are going to give the entire data to train our model. Hence all those data are called as training data. Here our problem is to find the price of an apartment. Okay, so to find the price of an apartment, we need the area of apartment instead of length and breadth. So we have to generate a new feature from the existing feature. Okay, that is, the three-dimensional data will be converted into four-dimensional data set. Why four-dimensional data set? Here we included the area in our data set, that is apartment length, apartment width and area. After that, price we are having, that is 3D is now converted into 4D. Okay, so general size we have additionally included in our data set. So this is the real estate data set. It's having apartment length, apartment breadth and apartment price. Okay, from this we are going to create the new feature, that is apartment area, by multiplying these two things. Okay, length and breadth. So we will get area. For this area, the price is 23,60,000. Okay, if the area is 4,720, right? So like this, we are going to extract the new feature from the existing feature. It's called as feature construction. In certain situation, feature construction is very much essential, and the situations are: first one, when the feature have categorical data but the learning algorithm requires the numerical data. Okay, for example, if we are having grade points but the machine learning algorithm requires the marks, in that situation the feature construction is essential. And the second situation is if the feature have numerical continuous values and need to be converted into ordinal values. Okay, so the numerical value should be converted into ordinal value. In that situation we need to extract new feature. And the third one, when text specific feature construction needs, then we need to be create a new feature. Okay, so these are some of the situation. In this situation we have to create new feature in our data set. Here the first one is encoding categorical nominal variable. Okay, for this we will see one example, that is a data set on athletics, and in the athletics table four features are there. First one is age in years and city of region, parent athletics, that is whether the athlete parents is also an athlete. Okay, and chance of win. Okay, so this is the target variable. Chance of win is our target variable, whether they are winning the game or not. Here the chance of win, this particular one is class variables and all the others are predictor variables. Okay, hence there are three features. First one is city of region and parent athlete and chance of win. Chance of win. So these three are the features, and the categorical and all these are categorical in nature and cannot be used by machine learning task because we require numerical value. And the feature construction can be used to create new dummy features which are usable by machine learning algorithms. So here the city of origin, city of athlete and chance of win both are categorical in nature, isn't it? So city of origin is three classes: city A, city B and city C. Right now based on this city of origin we have to create three different new classes. First one is origin city A, origin city B, origin city C. Okay, simultaneously based on parent athlete, here two classes are there, yes and no. So accordingly we have created new two features. The first one is parent athlete yes and second one is parent athlete no. Okay, and chance of win, this is also categorical in nature, yes and no. Accordingly we have created new two features, chance of win yes and chance of win no. Okay, and the values of those features may be either 0 or 1. So based on the categorical value. Okay, city A, when come to city A, origin city A, if it is city A the value is 1, otherwise 0. See, city A 1, otherwise 0. So likewise the values will be replaced in all the features in the table, right? So from this table, the parent athlete having only two classes yes and no, isn't it? So if it is yes, here 1 will come, here 0 will come. Here if it is 0 means this is 1. Okay, so those are the exact opposite to each other. Likewise, the chance of win, if it is yes means the no will get 0, right? If it is 0 means here 1 will come. So this is actually the duplicate data, right? So to avoid duplicate data we can remove these two features, right? So by using eliminating the feature so that we will get new set of features, that is age years and origin city A, origin city B, origin city C, parent athlete yes, and win chance yes. Okay, so these are the new set of features in our data set, and this is called as encoding categorical, that is nominal variables. And next let us see encoding ordinal variables, that is categorical ordinal variables. Here we will take the student data set with three variables: mark science, mark maths and grade. Okay, and here grade is ordinal variable. Grade is ordinal variables. The values are A, B, C and D. Right? Now the ordinal variable should be transferred into numerical variable. Okay, so that we have created a new feature called num grade. So in the num grade, we have to substitute the numerical value to the corresponding grade point. Okay, for example, A equal to 1, B equal to 2, C equal to 3 and D equal to 4. Okay, B equal to 2, 3, 1, 1, 4, 2. Okay, that is instead of A, B, C, D, here we are using the numeric value. And now let us see the transforming numerical, that is continuous feature, into categorical feature. That is, we need to transfer the numeric data into categorical data. Right? Sometimes it is very important. For example, let us take the real estate price prediction problem. Price prediction problem is regression problem. Okay, price category problem is classification problem. Okay, so here uh, the numerical data, that is the apartment price, that should be divided into multiple categories based on the data range. Based on the data range, the numerical data will be divided into multiple categories. So here the price will be divided into different range, that may be low, medium and high. We can divide those price range. And the real estate price prediction example, the original data has numerical feature apartment price, so this one, and it can be transformed into categorical variable, that is price grade. It may be grade low, medium or high, or otherwise the grade may be 1, 2 or 3. 1 means low, 2 means medium and 3 means high. Okay, likewise we can convert the numerical value into categorical value. The last one is text specific feature construction. That is feature construction based on text, right? So here text is very much helpful nowadays in the communication, that is medium of communication. For example, in social network, we are using only text, that is maximum text used in Facebook, Twitter, emails and WhatsApp, etc. Okay, hence the text mining is a very important area of research in both technology as well as commercial industries. So from text mining we can extract more number of information from the flow of communication, right? So the text area are unstructured in nature. The text data are unstructured in nature, and they are not readily available features in the text data. Okay, so it is not like structured data, but this is unstructured data, right? But the machine learning algorithm requires only the numerical data as input, right? So the text data in the data set, that to be converted into numerical features, then only we can use those data in our machine learning algorithms. So in the text data, the most popular keywords are converted into numerical representation, right? And this process is called as vectorization. Okay, here all the words which are occurred in the document are consolidated to form bag of words. The consolidated words will form as a bag of words, and there are three steps here. First one is tokenization, and second one is count, and third one is normalization. First, it starts with tokenize a corpus or document. Okay, here all the blank spaces and punctuations are used to separate the words or tokens. The words are otherwise called as tokens. Okay, if there is a blank space, then this will convert as a word, and the blank space occurs, then the R will become a word. Okay, likewise, all the words will be separated and the number of occurrence of each token is counted. Okay, that means how many are there, is are there, the are there, uh, words are there. Okay, and lastly, the tokens are weighted with reducing importance when they occur the majority of the document. Okay, so once the documents, that is the words, are counted, then weight will be given to each token. Okay, so based on the importance of that particular word or token, the weight will be assigned for each token. So based on the weight of the token, a matrix will be constructed. Here, each column represents the token. The token is representing a column, and each row represents the number of occurrence of particular word in the document. Document 1, 2, 3, etc. Okay, that means the cell, so here it contains the number represent, this will occur 2 times in document 1. Okay, this one, the number is 1, here the house will occurs 1 time in document 1. Okay, and this type of matrix is called as document term matrix, or otherwise term document matrix. So this is how the text value will be converted into numerical value, and this will be given to our machine learning algorithm, right? So far we have seen the feature transformation and the feature construction. So in the feature construction we have seen 4 different methods. First one is encoding categorical nominal variables, encoding categorical ordinal variables, and transforming numerical continuous features into categorical feature, and text specific feature constructions. So in the next class we will see another important topic from second unit. Thank you.